Welcome to Differential Equations, Chapter 1, Section 3. In this section, we're trying to classify different types of differential equations. So, this class is mostly going to be focusing on ordinary differential equations, hence ODE, not just PDE. There's other types called partial differential equations that we just won't get to. We oftentimes classify them in the highest order and whether they're linear or nonlinear. So ordinary just means that there's no partial, and this is the symbol for it, or at least the way I write it. It's really bad. But there's no partial derivatives, and partial is the exact opposite. The order is the highest derivative, which we'll show you on with a couple examples later. Linear means that there is no like y times the derivative of y. There's can be some similar cases, but we won't deal with any of those. And lastly, we have this Greek symbol phi, and that is what we use to call the solution of a differential equation. So we'll have this equation actually. This is going to be a second order differential equation. The way we know that is because it's got the second derivative of q of t. And so I'll just put that off to the side. And then we know it's an ordinary differential equation because there is no partial derivatives. It's just basic derivatives of one variable. And we know it is linear because there's no q times q of t or q of t times the derivative of q of t. With this second one, we have the partial derivative, u of u, partial derivative of x, function of x and y is equal to 0. We know that this is a partial differential equation because of the notation. We can say the order is 1, but we're not really going to focus on any of these. So we'll just go ahead and skip on to the next couple examples. So we got two more. Okay. And this one, we can say it's ordinary because there's no partial derivatives in this one. We can also say the order is 2 because of this second derivative. And we know it is linear because it does not have any y's multiplied by the derivative of y. This last one, we know it's ordinary again because there are no partial derivatives. The order, once again, is 2 because it's the second derivative. And we can say this is nonlinear because we have y squared times the derivative of y.